The equation for geometric mean is a over x equals x over b. Basically, to find the geometric mean of two numbers, you have to find the square root of their products.
To find the geometric mean of 4 and 9, you plug those numbers in for a and b. So the equation reads 4 over x equals x over 9. Next, cross multiply those two numbers to get 36 equals x squared. Then square root those two numbers to get 6 equals x. Therefore, the geometric mean of 4 and 9 is 6.
There are some important words to know for right triangles. The hypotenuse is always the largest side of the triangle that is opposite of the right angle.
The legs are the two sides of the triangle that are adjacent to the right angle.
Chapter 8 has many important theorems for geometric mean that can help you find many parts of a right triangle. An altitude goes across the triangle, which divides the hypotenuse into two parts, part 1 and part 2. Theorem 8.2 is part 1 of the hypotenuse over altitude equals the altitude over part 2. You're basically finding the geometric mean of the two sides of the hypotenuse. Theorem 8.3 is the hypotenuse over the leg equals the leg over the adjacent hypotenuse part. This can help you find many sides of the triangle.
This is an example problem for Theorem 8.2. In this triangle, the altitude breaks up the hypotenuse into part 1 and part 2. Part 1 is 16 and part 2 is 9. The altitude is just labeled x because we don't know the measurement. Now here, when you plug in the numbers to the formula, you get 16 over x equals x over 9, which is finding the geometric mean between 16 and 9. You cross multiply them and get x squared equals 144. Then find the square root and get x equals 12. Therefore, the altitude is 12.
In this right triangle, you are given the hypotenuse, which is 16, and the leg, which is 8. We are trying to find the hypotenuse side, which is labeled x. To find this, you'll plug in 16 and 8 into the formula, and you will get 16 over 8 equals 8 over x. Then you will cross multiply to get 16x equals 64. Next, you'll divide each side by 16 to get x equals 4. The hypotenuse side is 4.
On a baseball field, the base paths are each 90 feet. The distance from the pitcher's mound to home plate is 60 feet. If the catcher is attempting to throw a runner out stealing second base, how far is the throw? To set up this problem, you will use Theorem 8.3 and plug in 60 plus x as the hypotenuse, 90 as the leg, and x as the adjacent hypotenuse side.
After plugging the numbers in the Theorem 8.3, the equation is 60 plus x over 90 equals 90 over x. Then you cross multiply to get 8100 equals x squared plus 60x. Next, you subtract 8100 from both sides to get the equation of x squared plus 60x minus 8100. Then you would factor to get x minus 64.8683, x plus 124.868. You would have to take the positive number because the numbers can't be negative, so it would be 64.8683 is the distance from second base to the pitcher's mound. Then you would add that to 60 to get 124.868.
Now that we know what x equals, we can find y by using Theorem 8.2. We plug in 64.8683 over y equals y over 60. Then cross multiply to get y squared equals 3,892.1. Then you find the square root of both of these numbers and get y equals 62.386, which is the distance from the pitcher's mound to first base. The total distance a catcher would have to throw at a runner stealing second base would be 124.9 feet, and the distance the pitcher would have to throw to first base is 62.4 feet.